Hi everyone, myself Sudeep G. I'm currently pursuing computer science engineering in Sri Venkateswara College of Engineering. Today I'm going to explain about Introduction to DFA minimization. DFA minimization is the process of implication a deterministic finite automata. It's called DFA by reducing the number of states while pursuing the languages it accepts. It is an important concept in the automata theory and it is used to improve the efficiency of DFA operations. Definition of DFA minimization. Minimization state. In DFA minimization, the goal is to merge equivalent state to create a new DFA with the smallest number of states possible while retaining its functionally equivalence relation. It involves identification states that have the same behavior with respect to the input strings, establishing an equivalence relation between them. Optimization. The minimization process optimization, the DFA to reduce memory usage and improve computational efficiency. See, we show in this diagram the DFA minimization. Steps to minimize a DFA. Step 1. Deterministic finite automata. Start with an initial DFA that represents a formula language and defines its transaction and acceptance states. Step 2. State equivalence. Identify and merge equivalent state to create a minimized DFA. Step 3. Minimize DFA. Obtain the minimized DFA that has the smallest possible number of states while recognizing the small language as the organal DFA. Here we show in the diagram input of the unbounded length, unbounded number of states the transaction function have bounded. Examples of DFA minimization. Organal DFA. An example of a deterministic finite automata before the minimization process. Minimized DFA. The result of applying the minimized process to the organal DFA resulting in a simplified version with a favor states. State equivalence. Visual representation of the equivalent state before and after the minimization process. In this we solved in these figures. You can see this. Application of DFA minimization. Data compression. Minimization DFAs and used in the data compression algorithms to represent partners and reduce the size of the data. Lexel analysis in compilers minimize DFA and utilized for the efficient SQL analysis of a program languages. Pattern matching. Minimize DFAs plan a key role in the pattern matching algorithms enable quick and efficient recognition of pattern in the strings. Challenging in DFA minimization, state identification. Identification equivalent states in the large DFAs can be computationally intuitive, leading to complexity in the minimization process. Non-deterministic automata. Convergently non-deterministic automata to deterministic from before minimization can be challenging. Memory confusion. The minimization algorithm can require significant memory, especially for complex DFAs with numerical states and transactions. Techniques for efficient DFA minimization. Pattern refinement. Utilizing pattern refinement algorithm to symmetrically merge and refine equivalent states in the DFA. Table filling method. Implementing the table filling method to determine state equivalence based on the input transaction. Third one, Obscomp algorithms. Applying Obscomp algorithm for efficient DFA minimization by considering the characters of the input alphabet. Example, DFA minimization example. Today, initial state Q0, initial state accepting state Q2. This Q2 is a independent, it's a node and transaction Q0 to Q1, Q01 to Q2, Q1 to Q2, Q1 to Q1. Now let's check for the equivalent states and merge them. Q0 to Q2 are not equivalent because they have different outgoing transactions for the both 0 and 1. Q0 to Q1 are equivalent since the transaction for Q0 and Q1 are the same from both 0 and 1. Merging Q0 and Q1 into a single state, let's call it Q, gives us the minimization DFA. State Q0 to Q2. The minimization DFA represents the same language as the original bit with fewer states. Here see we Q0 to 2 its connection B it's a Q1 to Q2 Q1 Q2 transactions the Q1 to Q2 A Q1 to Q2 Q1 to Q2. Here you can see the transaction tables. DFA Q0 connected to Q1 and Q2. It's a single node. It's connected with same node A comma B. It's also connected with same node A comma B. Conclusion and key takeaways. Optimization automata. DFA minimization is a circular for optimization automata leading to improved performance in the various applications. Practical significance. Understanding the significance and challenges of the DFA minimization is essentially for the engineers and develops in the fields such as computer science and software engineering. In this minimization optimization, we can see minimization a DFA is circular for the optimization and it reduces the number of states and transactions, make the automata more efficient in terms of memory and computation. In this, we can see language prevention. DFA minimization ensure that the minimized automata recognize the same language and the organized DFA maintaining the equivalence of accepting strings. In this, we can use the unreachable states also. States that can be reached from the initial state or do not lead to an accepting states for an input can be safely removed during the minimization. And we can use in this continuous research. Organal research in the automata theory and algorithms is forced on enhancing the efficiency and applicable of the DFA minimization techniques. This is the whole explanation about DFA minimization.